Hello guys and welcome back. In a previous video we saw how to use a tree diagram, a two-dimensional grid, and a list to represent the sample space for flipping two coins. Now we're going to continue doing the same thing with these independent events, and remember those representations help us to find answers to certain probability problems. We're having a simple example here of flipping a coin and rolling a die simultaneously. So what we want to do here is to find the probability of getting a head and a 5. So the interpretation of our problem gives us what you can see here. For the coin we have two possibilities, either a head or a tail, and for the die, because we got 6 faces or sides, we're gonna have 1, 2, 3, 4, 5, and 6. And the probability of having a head out of these two side of coins here is what we can see here is going to be this one. This is the head here, so its probability is going to be 1.5. Okay, 1 out of 2. And the probability of having a 5 here, this is only 1 here, this is going to be 1 out of 6 possibilities. Now we can represent that in a two-dimensional grid. Oh, I'm missing an A here. Two-dimensional grid. Okay, as you can see here, we represent the coin. We got only two possibilities, the head and tail, and the die on this side here. So let us just represent what we got here before. The coin, we said it was 1, 1.5, means that it is something like here. We got a head, and this is one possibility out of 2, so this is going to be here. And for the die, we say having a 5 will be one possibility out of 6. So 5 is here, and it's one possibility right here. But still, we have a lot of possibility. Okay, so it means that if we want to find together how to get a head n, but this is what is very important here, is this n here. We want to have together, the probability of having a head and a 5. So we're having a head here, a head with a 5. It means that what we have a head here and a 5 is actually here. The 1 and the 5, the head and the 5 is actually here. As you can see, head and 5. So this is 1 out of, but we still have a lot of other possibilities. We still have this one, we still have this possibility. Let me take a different color. We still have this other possibility, that one, that other one, this one here, that one, this, and that. I forgot this one here. So as you can count here, we have 1, 2, 3, 4, 5, and 6. Oh, I forgot a 6 here. There is okay, sorry. As you can see, we have 1, 2, 3, 4, 5, 6 times 2 will be 12 possibilities. Okay, this is going to be 12 possible outcomes, but only one with the property that we want. This is this one here. This is the only one which has the property we want. So our answer will be, so we said the probability here, let us say the probability of having a head and a 5, a head and a 5, is here equals to 1/12, and this is here our answer. Still, we can do that separately as we did here. You see, with a two-dimensional grid, it's easy to rate it out, but we can also do the separate. So we said here the probability of having a head was, is 1.5, and the probability of having a die, a 5, pardon, is 1/6. Okay, so we can say that, put them all together, this is what we need, is the probability of having both the head and a 5 equals to 1.5 times 1/6, and this is gonna give us again 1/12. Now this tells us that the probability of having a head and a 5 is equal to the probability of having a head times the probability of having a 5. It means that we just multiply the separate probabilities. And this brings us to say, therefore, that for two independent events, A and B, the probability of having A and B is equal to the probability of having A times the probability of having B separately. And this is the basic formula to use when it comes to independent events. And these type of events have this property that the occurrence or non-occurrence of A cannot affect the occurrence or non-occurrence of B, and vice versa. It means that A can happen independently from B and B happen independently or occur independently from A, and this is what we call independent events. Okay, thank you for watching again. In the next video we're gonna go ahead doing complementary events and dependent events and a couple of examples. Bye bye.